So here's a question. Again, we will do more involved examples when we meet in class. We will do as much as we can here, but you really have to, again, start understanding what is happening with configurations here. The question is, are these enantiomers or the same molecules? So you have two ways of doing this. You can imagine these in your head, which we can, but that would take us a long time. Sometimes we get frustrated. You should have, let me say this, you should have kind of a skill in rearranging things or just moving them a little bit, because it actually helps not only in this class, but outside of class. So those visual skills. But then after that, we can just simply use what the system is giving us. The system gives us very, very simple rules to follow. So remember, you say you start with assigning RS. So start with assigning RS. And there's one thing to keep in mind, that if you have R as one configuration, its enantiomer, okay, will be the S. So these are enantiomers. You saw this with ibuprofen, the R and the S. Both are enantiomers. What do you think if I have R and R? What would that make them? Same molecule. So let's begin. Very simple example. Br would be number 1, Cl would be number 2, F would be number 3, and of course H would be number 4. So this goes from 1 to 2 to 3. And what movement is it? What movement is that? That's an S. That's counterclockwise. So that would be S. To determine how they're related, you can do the same thing. Now we say here's 1, the priorities did not change, but there was a switch. The Cl and the F were switched. So that would be 2, and that would be the 3, and that would be the 4. So let's draw our arrow, yep. And now what is that? That's clockwise, which is R. So you say that these are what? Enantiomers. Enantiomers. Now the other method is, it's a simple method. It's really the same thing as, of course, you determine 1, like we just did, 1, 2, and 3. And you just ask yourself this question: was there a switch? Was there a switch? And yes, right here we see there was a switch in atoms. Switched. And here's the key word: once. Then guess what? If you find that this is S, then automatically if there was a switch between 2 atoms, just one switch, then that would be an R. If it was 2 switches, it would go back to the same molecule. So be very careful. If the atoms switch once, then they are enantiomers, given that they are chiral compounds in the first place. So keep that in mind. And don't overthink it. It's not meant to for you to overthink it. Again, you use these RS rules to help you.